So we just finished an awesome activity about correlation. Correlation, they use the letter R to distinguish correlation. It's some sort of number between -1 and 1. It's fancy math talk right here, between -1 and 1. And what correlation measures is how strong something is. So it measures the strength and the direction. Strength and direction. So let's rock through this, man. It's like, what if that R value from what we saw was really, really close to 1 or -1? Would you consider that strong, weak, or moderate? That would be strong. Strong, 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 strong. So that would be a strong fit. If that number is close to 1 or -1, that would be a strong fit. What if that model is close to 0? I don't care if it's on the positive side or negative side. Strong, moderate, or weak? That's weak. That's weak. And then this is saying if R is exactly 1 or if R is exactly -1, that would be a perfect fit, dude. A perfect fit. If you had a model to where the correlation is 1, or if the correlation was -1, then that model was a perfect fit for whatever scenario you were talking about. 1 is perfect, -1 is perfect. If R equals 0, there's no linear relationship between those two variables. There is no linear relationship. And then here's the part that some of us might struggle with, knowing these symbols on homework. Which one is the green one, a less than or a greater than? Which one is the green one right here? This guy? That is a less than. So talk to me. If the R value is less than 0, is it positive or negative? Negative. If R is less than 0, that's a negative. And if R is greater than 0, that is a positive. And then you might put a box around this right here. This is going to be like something, grab one of those worksheets right there. This is going to be something that you probably want to look back at. A correlation greater than 0.8 is strong, right? Whereas it's less than 0.5 is weak. So something in between those numbers is going to be moderate, right? So when you're answering questions on homework, they're like, is it strong, moderate, or weak? If it's bigger than 0.8, that's going to be strong. If it's less than 0.5, that's weak, and everything in between is moderate. And same with the negatives. So boom, here we go. This was the candy grab. I kind of rearranged the activities. We did the candy grab last time, and this was our data from it, so I really don't care about doing that again. Let's just answer these questions. This was how wide someone's hand was. This is how many candies that we grabbed in here. Talk to me. Is the R value greater than 0, or is the R value less than 0? Or let me put it in English. Is R positive, or is R negative? What do you think on this guy? That guy is positive. So, boom. Is R closer to 0 or closer to 1 on this guy? What do you think? Is R closer to 0 or closer to 1? See that? See that? See that? Is R closer to 0 or closer to 1? I would say it's closer to 0, right? Because even though this isn't bad right here, this outlier kind of messes things up on that one, so I would say R is closer to 0. Let me circle that properly for the video people. R is closer to 0. That's pretty weak association. Quick little example here. To see if a seat location affects test scores, so like where you sit in the room, does that matter what you get on a test, you know? Statistic teacher randomly assigned students seat locations in his classroom for a particular chapter and recorded the test score for each student chapter. And then the explanatory variable is what row they sat in. So they had 7 rows in there, and they wanted to see what they got on the test. Let's just look at it. What do you think? Positive or negative correlation on that guy right there? It's pretty loose, right? But I think it's not a true 0. I would personally say it is negative, but isn't it very, very, very weak? Are you with me on that? That's very, very, very weak. I wouldn't even be opposed to someone saying a 0 on that. So because the relationship row score is negative, that's what I think. It is negative. You're pretty much usually going to have to make a decision on it being negative because you can see most of the dots kind of go in a downward fashion if you was to look at them individually. Fill this in. R is what to 0? Greater than or less than? Greater than or less than? What do you want? Less than? Because it's negative. Also, R is close to what then what? Like between 0 and 1, one of these blanks has to be filled in with a 0, and one of them has to be filled in with a 1. So which one is this guy closer to? Closer to 0 or closer to 1, this relationship right here? This one is closer to 0 than 1 because the relationship is weak. So you'll have drop-down menus just like you do on homework. I just don't type any drop-down menus. But because the correlation is closer to 0, that's got to be weak. Cool. I will let you read this and give it a shot with your neighbor. You just got to circle which one is correct. So check it out. They give me the R value right here. They gave me the R value. Pretend he's positive for a second. Is that guy closer to 0 or closer to 1? Pretend he's positive. Closer to 0 or closer to 1? 0.8, you know, closer to 0 or closer to 1? Closer to? Pretend he's positive, please. Pretend he's positive. Is 0.8 on the number line closer to 0 or closer to 1? Here's 0.5, guys. Is 0.8 closer to 0 or closer? It's very much closer to 1. Strong or weak? Strong. Positive or negative? You should never get that wrong when they have the symbol in front of it. Is this positive or negative? Thank you. Thank you, thank you, thank you. Boom. Here's what we can't get like ahead of ourselves. Would you agree that these dots right here are not linear, right? Only thing we've done today is linear situations. Just because it's not linear doesn't mean there's a strong correlation. Would you believe that this is a very, very strong nonlinear correlation right there? It fits that curve really, really well. So this correlation is very strong of 0.93. It is very close to 1, and it is positive. So we will learn some graphs make more of a curved shape than a straight shape in that case, but just because it's not lined up doesn't mean there's not a strong correlation. And then lastly, do not assume that correlation implies causation. Here's the story. Most people love chocolate for its great taste. I know not everybody does, but most people do. Does chocolate make you smarter? What would you think about that? Yeah, if you eat chocolate, will that increase your intelligence? Probably not, right? You know, probably not. But here's what they did. They measured how much chocolate per year the resident in these countries eats versus their how many Nobel Prizes that country has won. And if you just look at the dots, would you say that is a pretty moderately strong correlation? And they even tell you it's 0.791. That's almost strong. Like strong is 0.8 or above. This is almost strong. So do you think that just because the correlation is strong, that means that chocolate would cause high intelligence? Does correlation mean that that's going to cause things? And this is the thing in the box. Correlation does not mean causation. Just because things correlate tightly doesn't mean that one thing causes the other, right? Correlation does not cause things. Eating chocolate does not cause you to get smarter. So what do you think? Let's interpret this real quick, just simple words. Sorry, that's not an eraser. Let's interpret this. Positive or negative is how you'll do it. Wow, sorry about that. Positive or negative. What do you think on this, dude? Positive. And then please decide if it is weak, moderate, or strong. Weak, moderate, or strong. I put that it is moderate. Just because they told us on the front side of the worksheet that 0.8 and above would be strong, you know. So this is like the strongest version of moderate you can get, you know. If you said that it was strong, I couldn't be mad at you, you know, but maybe the homework program is going to say that you're wrong. So 0.8 and above is strong. 0.5 and below is weak. And then If people in the U.S. started eating more chocolate, can we expect more Nobel Prizes to be awarded? What do you think? If we eat more chocolate, do we win the Nobel Prize? Yes or no? What do you think? Can we expect that? I would say probably not. You know why? Because correlation does not imply causation, is the moral of that story. Just because there's a correlation between those two things that we studied, that does not mean that eating chocolate is going to cause us to get smarter.